Today we will discuss about complex number. So we discuss about what are complex. We will discuss about what are complex numbers. So we share our screen. So first of all, we will define it topic by topic. So first of all, we will define what is definition of complex number. So then their examples. So complex number are the numbers that are expressed in the form of a plus iota b, where a and b will be real number and iota will be the imaginary number. So value of iota will be equal to square root of 1 is 1. If we write 2 plus 3 iota, so 2 is real number and 3 iota is an imaginary number. So you can write 3 as an imaginary part. So there are some examples of complex numbers. So an imaginary number, we will show imaginary number by iota. So means the application of this number, there are some application of complex numbers. So they are using periodic motion such as water waves, alternating current, light waves, which rely on the sine and cosine of waves. So here we will discuss gradually what will be the value or what will be the definition of complex number, absolute value, algebraic operations, formulas, power of iota identities, properties, modulus and conjugate, argon, plane and polar representation, example, and some of the queries related to complex numbers. So definition is a plus iota b. We had discussed definition and some of the examples. So this is proper form, you can say standard form of complex number. This will be real part and this whole will be the imaginary part. So what is real number? So we know that real number are you can say positive, negative, zero, integer, rational, irrational are the number are includes in real number. So what are imaginary number? Imaginary number are where you can say iota. So any number where you see iota are called imaginary number. What is notation to show the complex number? C is equal to a plus iota b. Here is a real part and b is the imaginary part. So iota b will be the imaginary part of real number. So we will show the complex number by z, small z. And there are some examples of complex number, real number, and imaginary number. So these here in complex, this complex number, this is real part, and this is imaginary part. So you can write it as purely imaginary number, and here where real part is zero, so it is called pure imaginary number. Is zero a complex number? Yes, you can say that zero is a complex number because you can write 0 plus 0 iota, so 0 will be the imaginary part of that complex number. So graphical representation is same as the graphical representation of real number. So this will be the real axis, this will be the imaginary axis. Then here we will put real values and here we will put imaginary values. So if there is question 3 plus 4 iota and we have to find the quadrant. So this is first quadrant, second, third and fourth quadrant. So you can also write 3 plus 4 iota in order form. So in order form this will be 3 plus 4 iota. So similarly, if we write this is example of numbers. So similarly, if we discuss further, then this will be equal if I erase this. So this is complex number. This is graphical representation of a complex number. So what is absolute value? In absolute value of complex number, you can say modulus of complex number. So if c is x plus iota y, so we will write real part square plus imaginary part square. So this will be the The expression is obtained when we apply the Pythagorean theorem in a complex plane. Hence, modulus of complex number c is extended from 0 to c, and mod of real number x and y is extended from 0 to x and 0 to y respectively. Note these values form a right triangle where 0 is the vertex of the acute triangle. Now, applying, if we apply Pythagorean theorem to z, mod will be equal to square root x square plus y square. So this is modulus of complex number. So here are also operations like addition, subtraction, multiplication, and division. We can apply these operations. If we apply these operations to roots of the complex number, when we solve a quadratic equation in the form of ax square plus b, so what are the roots? So roots can be distant real roots, similar roots, and complex roots. Complex number forms, this is addition of complex number, this is subtraction. Similarly, there is multiplication and division of complex number. So power of iota, if we discuss the power of iota, so we know that iota square will be equal to -1. Depending upon the power of iota, it can be taken the following values. Iota 4k plus 1 is equal to iota 4k plus 2 is equal to -1. Similarly, iota 4k plus 3 is equal to minus iota dot iota 4k will be equal to 1. We can where can have integer value positive or negative. Similarly, if we write iota minus 1, this will be 1 over iota. Similarly, we can solve it as and can find the answer. This there is an important property. If we write minus iota multiply minus iota, this will be equal to square root of minus iota minus 1 minus 1 will be equal to plus 1. So this contradicts the fact that iota square is equal to -1, because this is if I write some notation here, as you see, for this, what is this contradiction? If I write iota square will be equal to -1 square root, iota square is equal to -1. So -1 square root square, because this iota square can be written as iota multiply iota. So this will be equal to square root of -1. Similarly, square root of -1. So this will become like this expression. So further, if we take, this will be equal to this will be cancelled out. So this will be equal to minus. You can write it as square root of -1 multiply -1. So -1 will be +1. So this will be equal to 1. So this can be equal to 1. So what is here the difference? Because how -1 will be equal to 1. So this is a contradiction. Why this is a contradiction? Because we had this we had applied this property, which is wrong. Because here, if we know that the property a b is equal to square root of a and square root of b. Okay, so here for application of this property, one value should be positive and one value should be negative. So because here both the values are negative, so this property is wrong. So this was the contradiction. Therefore, for an imaginary number, square root ab is not equal to for imaginary number, you can say that square root of a multiply square root of b is not equal to square root of a and b, and this is equal for other numbers. you can say the real number, integers, and any kind of the number. So there are some identities in complex numbers. So we will discuss about these identities. Let us see some of the identities. Z1 plus Z2 square will be equal to Z1 square plus Z2 square plus 2C1 2C2. Similarly, Z1 minus Z2 square will be equal to Z1 square plus Z2 square minus 2C1 to Z2. Similarly, Z1 square minus Z2 will be equal to, similarly, as we have formula A plus B and A minus B, this will be clear for this for two complex numbers C1 plus C3. So three for third formula for the power degree of 3 will be similarly applied as the formulas were applied in real numbers. So some of the properties of a complex number. The properties of complex number are listed below. The addition of two conjugate complex number will result in a real number. If we take uh, two real number, uh, the addition of two conjugate complex number will result in a real number. Two conjugate complex number. Simply, if I write 2 plus 3 iota, and conjugate of 2 plus 3 iota will be equal to 2 minus 3 iota. So if we add, so our result is a real number. How real number? Because uh, if we add these two numbers, so plus 3 will be cancelled out with minus 3. So you will write 2 plus 2 will be equal to 4, because this is real number. So if we add a number, complex number, and its conjugate, our final answer will be a real number. Similarly, the multiplication of two conjugate complex number will result in a real number. Similarly, if we multiply these two, so our result will be uh, a real number. So here our result will be equal to 4 plus 3 3 are 9. So this will be equal to 13. Uh, what is 13 and where from you get 13? If we multiply these two number, our result will be equal to 13. Similarly, if x and y are the real number and x plus iota y is equal to 0, then x will be equal to 0 and y will be equal to 0. If pq, r, and s are the real numbers and pq I plus RSI, then P will be equal to R and Q will be equal to S. This is an important property. If two numbers are equal, then their corresponding number will also be equal. The complex number obeys the commutative law of addition and multiplication. Here, this is an also important property. If we add two real numbers, this will be complex number. So C1 plus C2 will be equal to C2 minus C1. Similarly, C1 multiplies C2 will be equal to C2 multiply C1. So here you can say the commutative property of addition and multiplication is hold and verified in complex numbers. Some of the other properties of complex number. The complex number obeys the commutative law we had discussed. The complex number obeys the associative law of addition and multiplication. It is an also important property that associative law also hold in complex number. The complex number obeys the distribution law. This is an other important property that complex number obeys the distributive law. This is distributive property. C1 will be multiplied by C2, C1 will be multiplied by C3. If the sum of two complex number is real and also the product of two complex number is also real, then these complex number are conjugate to each other. For any two complex number, we said that C1 and C2, this is called, you can say this is triangular inequality. For any two complex number, Z1 plus C2 mod will be less than equal to C1 mod and C2 mod. Okay, then the result of the multiplication of two complex number and the conjugate value should result in complex number and should be positive value. So after that, we will discuss about the modulus of complex number. So what is modulus? And we will discuss about what is modulus and what is conjugate. So we had discussed earlier. So similarly, we will do this here also. As what is modulus? Modulus is, we had discussed about modulus. Modulus, if a plus b iota b is complex number, so modulus will be equal to a square plus b square. So conjugate of c is denoted by c bar. So similarly, if a plus iota b, so we will change the sign of iota. So this will be the conjugate. So there is an important property of conjugate. This is first quadrant and this is our second quadrant. Similarly, this is our third quadrant and this is our fourth quadrant. So if a number is in first quadrant, point is in first quadrant, then conjugate will be in fourth quadrant. Similarly, if uh, point is in fourth quadrant, so conjugate of that number will be in first quadrant. Similarly, if a point is in third quadrant, so conjugate will be in second quadrant. If a number is in second quadrant, the conjugate will be in third quadrant. Similarly, if a number here is so conjugate will, this is an important property which tells us about the shifting, because here if we point is in second quadrant, so this will be shifting our third quadrant. So this is an important property of the complex number. So similarly, modulus, we can show that if a number here is number, so modulus will be that distance. Here will be the y-axis, and if we change, here will be the y-axis and here will be the our x-axis, and this distance will be c bar. We will take, you can take this distance in real number as r. So this is called the modulus of complex number. So after modulus we will find the after modulus, if we clear all and this, after modulus we will find the argand plane and the polar form. What is polar form of the uh, complex numbers? Argand diagram, if we show a complex number in a diagram, this is called, this is real axis, this is imaginary axis. So this diagram which show the geometric representation of complex number is called the argand plane, or you can write it as argand diagram. So after argand diagram, we will show the what is polar form of complex number. So what is polar form of complex number? In polar form, we have to find r and theta. So we know that theta is equal to tan, you can write it as tan inverse y over x. Similarly, if we want to find r, so r will be equal to sine x, r will be equal to x cos square theta plus, you can simply take x is equal to r cos theta. Similarly, y will be equal to r of sine theta. So this r will be the modulus of complex number we had discussed earlier. So what is modulus? Modulus will be equal to r will be equal to square root of x square plus, you can write as y square. So r will be equal to square root of x square plus y square. This is a procedure to convert in to the polar form. So you can convert rectangular coordinate to polar, a complex number in from rectangular coordinate to polar, and similarly if a coordinate is given in polar, so you can convert that point in